Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the LeetCode, which is minimum falling path sum. It is the 12th problem of the dynamic programming series. If you haven't watched the previous videos, you can consider watching them since it will be really helpful for you to understand the concepts in upcoming videos. So let's start the discussion on this question. So this question says that we are given an n cross n array of integers and we have to return the minimum sum of any falling path through the matrix. So here the definition of the falling path is given. Let me explain it in brief. So the falling path says that, for example, if we are standing at this particular index, then the ways we can move is we can move to left, we can move either down, or we can move to the right. So these are the ways that we can move is possible. For example, if we are standing at this particular index, then we can't move to the left index since there is no cell available. We can just move to down and right. So this way, the question says that we are required to return the minimum sum of any falling path. So what does it mean to say is that if we start a journey from, let's consider this particular index, then what all ways are possible? It can move to 5 and then it can move to 8. So this is one path. And the other part that can be considered is if it from 1 to 6 and then to 8. And similarly, some other path is like, yes, 1 to 4 and then to 8. So let's check like what is the sum of all the paths. So for the path represented by yellow, the total sum is 13. And similarly for the path that is represented by violet is 15. And similarly for the case of red is it's 14. Yes, it's 14. So from all the paths, we have to consider the one which has the minimum sum, which is 13. So we are given as a starting point is first row, and we can start from any of these indices, and then we have to reach till the end row. And after that, we have to determine which is the smallest sum. So the naive approach that may come up to your mind is like we can just iterate over all the indices. For example, for this particular case, what we will do is we'll create a function and we will pass this particular row and column and the total sum, which will be initialized to 0. And then we can move to next row and the previous column, and sum will be increased by a of r c because we are counting this sum this value also. And the other way that is possible is we can move to the next row, but the column is same, and sum plus a of rc. This is one way possible where we move to the down, and the last way that is possible is function of next row and the next column as well, and sum will again be same plus a of rc. So basically these are the only three ways possible, and out of these three ways that the way that brings out to the minimum sum, we will just return that. So we have to do this process for every index, right? So the time complexity, if we observe, is since every time our path is being divided into three, so the total 3 will be multiplied by every time 3, and next time also it will go to 3. So the total number of ways are just increasing. So in this case, the complexity will be that 3 multiplied by the total number of rows. Let's consider it to be n. And since we are iterating over all the indices, so this is for single index, and this will be multiplied by n, m, in case we have m indices. So this complexity is really high. So we need to think of something that is optimal. So what we can do is, let me clear this out. Yes. So what we can do is, let's consider the first row that we are, in case we are starting from this particular index, which is the first index. So what is the minimum possible sum if we reach at this particular index? Since this is a starting index and we are ending at the same index, so the minimum sum that will be possible is this value 2. And if we move to the next index, similarly, since the starting and the ending point are same, so the answer will be 1 for this case. And if we are at the last index, again the answer will be same. But here is where the transition takes place. Now if we have to reach at this particular index, then what are ways are possible? Then the ways that are possible are, yes, so we can reach this index from here as well as from here, because if we see that if one moves to this place and two moves to this place, so we can reach to this particular index from both the sides. So we have to consider the one that will take the least sum. So out of these two, since it can reach here also and here also, so which is the minimum? One is the minimum. So basically 1 plus and the sum of the index itself, it will be 7. And for this case as well, since how can we reach up till this index? We can reach from this 3, this 1, and this 2. So we will be considering the minimum value out of these three: 2, 1, and 3, which is 1 again. So 1 plus the value of that index itself, which is 5. This answer will be 6. And if we have to reach till this index, similarly, the minimum value between 1 and 3, which will be 1, and the value at index itself, which is 4. So here it will be 5. So this represents that for this particular row, these all values are the minimum sum that is required to reach them from all the paths. And similarly, we'll be doing from for the last row also. So if we have to reach this index, we can reach from 7 and 6. So which is the minimum value out of them? It is 6 plus the value itself, 7. So it is 13. And now if we want to reach this index, then we have three options. We can reach this index from 7, 6, and 5. So out of the three, which is the minimum value? It is 5. And 5 plus the value at the index itself, it is 13. Now we are at the last row and the last column. So how can we reach here? We have just two ways possible. So out of these two, which is the minimum value? It is 5 plus the index value. It is 9, so 14. So now the question was just to return the minimum value that is required to reach the last row. So we will just iterate over the last row and all the indices and just return the minimum value, which is 13. So this is our answer for this particular case, as you can see. So let's code it up. I'm renaming this matrix to A, and I'm declaring a new matrix dp. Now I'll be initializing, since this is our dp array, and this is our original array that was given to us. Since the first row is same, so I will be initializing the first row of the dp array. It is dp of 0 is equal to, and now we will start iterating all the indices. So the I variable is for iterating over rows and j is for iterating over columns. And we have to store our answer is if we are at the 0th column. If j is equal to 0, then we need to do something, and else if j is the last column, then we need to do something else, and the last else case is different. So if the column is first, basically 0th column, so for this case only two ways are possible. It can come to this place from only two sides, up and right. So dp of I of j is equal to minimum of dp of I minus 1, basically the previous row, and the same column, and previous row, and the column ahead, and we will just add the value of current index, which is a of I of j. So one change here is if it is the last column. So these are the only two ways possible how we can reach at this index. So it will be minus 1, basically the previous index and the previous row. And in case if we are standing at any other position, then we have three ways possible, which is dp of I minus 1 of j, and math, and the previous row and the previous column and the previous row and the column ahead. And we have to simply return all. So this is, we have built our dp array. This is this part of the code, we have built our dp array, And now just we need to iterate over the last row of this DP. So let's initialize min variable with maximum value, and let's iterate over all the indices. We have to just return this minimum value. So let's check if our code is correct. So we have made mistake dp of, okay, so basically last row n minus 1 and I is for columns. So here we are missing that we haven't added, yes, for this case we haven't added the value of the index itself. So that's the reason it is giving wrong answer. Yes, now it is correct. So hope you understood the solution, and in case of any queries you can comment down below. I'll be answering them. So that is it from my side. So if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Thank you.